Hello and welcome to Maths with Jacob. This lesson will focus on cosine ratio. In the last video, we explained the meaning of the sine ratio. This video will explain the meaning of the cosine ratio. If we remember, cosine theta is abbreviated to cos theta. In the diagram to the right, we have drawn a right-angled triangle with the appropriate labels. We saw this in the previous video. So here we have our angle that we've chosen, unknown angle theta. Once that is fixed, all those sides then have specific names. That's the opposite side because it's opposite to the angle. That's the adjacent side because it's adjacent or next to the angle. And this is always the hypotenuse because it's opposite to the right angle. Cos theta is defined by a special ratio as follows. Cos theta equals adjacent over hypotenuse. So cos theta will be the adjacent over the hypotenuse. So it's the length of this side over the length of the hypotenuse. We can use this formula to find the lengths of unknown sides in a right-angled triangle when we are given the appropriate information. Let's look at example 1. Find the value of k in the following triangle. So if we remember from the previous slide, cos theta equals adjacent over hypotenuse. So cos theta will be k over 24 because k is the adjacent and 24 is the hypotenuse. So that's the first line. Now if we multiply both sides by 24 centimetres, we get k equals cos 60 times 24 centimetres. Cos 60, if you use your calculator, is 0.5 times 24 centimetres. And that gives us 12 centimetres. So the length of k is 12 centimetres. Example 2. We have to find W. So there's the angle, there's W, which is the adjacent, and there's the 16, that's the hypotenuse. So cos theta equals adjacent over hypotenuse. We want the answer to two decimal places. So cos of 50 is W over 16 because it's adjacent over hypotenuse. Multiply both sides by 16 centimetres. So W gives us cos 50 degrees times 16 centimetres. If we use the calculator, the answer that we come up with is 10.28 centimetres to two decimal places. That's what the direction was up here. And when you see the answer on the screen of the calculator, you'll have a lot of numbers here after the decimal place. But you must only have two numbers at the end because I said two decimal places. So this video has introduced the idea of cosine theta, which is abbreviated to cos theta. And we've seen two examples where we can actually use this ratio to find the lengths of unknown sides in a right-angle triangle.